Hello students, in the today's class we are going to talk about the hydrolysis of the salt which is obtained from the weaker acid and weaker base. In the earlier video classes we were discussed the hydrolysis of stronger acid and stronger base salt. The salt which is formed from the stronger acid and stronger base, the salt which is formed from stronger base and weaker acid, the salt which is obtained from stronger acid and weaker base. They were all given in the earlier video classes, and this is a continuation of that. This is the fourth part. Weaker acid, weaker base. What would be the best example for this? Consider this one, CH3COOH, acetic acid. If it is in action with ammonium hydroxide, both things are weaker, acetic acid and ammonium hydroxide. They are the weaker acid and base. When they are reacting with each other, we can have a salt like this, CH3COONH4. And in addition to that, the water, H2O, which is in the form of liquid. The name of this salt is ammonium acetate. Yes, we are obtaining the ammonium acetate. This ammonium acetate is the best example of this category of salt. The salt of weaker acid and weaker base. How this is getting hydrolyzed? CH3COONH4, ammonium acetate. While the hydrolysis that is giving you CH3COO minus acetate ion and then NH4 plus ion, ammonium ion. If you consider the acetate CH3COO minus during its hydrolysis on action with water, then what happens? It is converted into CH3COOH and the other product would be OH minus. Actually, acetic acid is formed and one of the hydroxide is formed. It means the acetate is having better tendency to combine with the hydrogen plus of water molecule. Yes, it is a conjugate base of this particular acid, acetic acid. Its conjugate base is CH3COO minus. It has got a strong tendency to combine with the H plus to form a product like this. It shows that there will be decrease in the concentration of H plus. Likewise, if you take ammonium NH4 plus ion, that is also hydrolyzed by using water to become NH4OH plus H plus. It shows that the ammonium ion, the cation, which would be the conjugate acid of this particular base, NH4OH. The NH4 plus is the conjugate acid of this particular base. This conjugate acid readily combines with OH minus of water molecule to become ammonium hydroxide. It shows that there will be drop in the concentration of OH minus. So we can come to the conclusion both hydrogen plus and OH minus decreases. So the decrease in the concentration of H plus as well as the decrease in the concentration of OH minus. So how to predict whether the solution is acidic or basic? That can be discussed based on the strength of acid selected and the strength of base selected, which can be explained as follows. Okay. The strength of acid is greater than that of strength of base. We can say that the Ka value would be greater than that of Kb. It means the resulting solution of the salt may have the following nature. It might be acidic in its nature, and if you calculate pH, pH will become lesser than 7. So this is the first condition. When the strength of acid is greater on comparing with the strength of base, Ka would be greater and the resulting solution is acidic and pH is less than 7. Otherwise, the other condition, suppose the strength of acid is lesser and the strength of base is greater, means just opposite to that, Ka is lesser and Kb would be greater. So the salt solution of the salt after hydrolysis, its nature must be basic and its pH value would be greater than 7. So these are the points to be recollected regarding the hydrolysis of the salt obtained from the weaker acid and weaker base. The condition 1, when the strength of acid is greater, the corresponding Ka would be greater and the solution is acidic in its nature and its pH is greater than 7. Otherwise, when the strength of base is greater on comparing with the acid, the Kb value would be greater. Due to that, it would be basic in its nature and its pH would be greater than 7. And in order to calculate the pH, we can have the relationship in between Ka and Kb and the hydrolysis constant. This product is equal to the Kw. And previously we were noted that Ka into Kh is Kw or Kb into Kh is Kw. Here both dissociation constant of weaker acid and weaker base is considered and the relationship is obtained like this. And with the help of this, if you want to calculate the pH of the solution will be 7 plus half of pKa minus half of pKb. This is the final relationship that can be obtained. And we were explained how to get the relationship in all our previous videos. Just you can refer that. Otherwise, it's a last step. By using this, we can get the pH. According to the relationship, when the pKa is considered and when the pKa is plus, the pH is equal to 7 plus half of pKa minus half of pKb. It shows that pH might be lesser than 7 or pH may be greater than 7. Lesser than 7 means the solution is acidic and greater than 7 means the solution is basic. This is according to the strength of the acid and strength of base. So this is the last category of salt hydrolysis. Is it clear? Yes.